Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 7.4, Problem 7. This is Section 7.4, Problem number 7. It says, Goodyear has a new type of tire. They have determined that the number of miles that can be put on it before it goes bald is normally distributed with a mean of 53,495 miles and a standard deviation of 1,500 miles. They want to offer a warranty where they will only have to replace 1% of the tires that they sell. How many miles should the warranty be? So this is a pretty realistic problem. This is how a lot of warranties are determined. The key to getting this one started again is the phrase normally distributed. Because there's that phrase normally distributed in the problem, what that means is the problem is going to involve the bell curve and the chart that goes with it. So the middle number on that bell curve is the average, which is 53,495. And you can do this whole problem without drawing a picture, but I think it helps. So they only want to replace 1% of the tires. So 1% as a decimal is 0.01. So we want to know what the number of miles would be at that point, so that there is the probability of having less than that number of miles on the tire before it goes bald is only 1%, or as decimal 0.01. So what I want to do is I'm going to use the z-score formula to find the number that I want to find. And the z-score formula is z equals x minus the mean over the standard deviation. So I have an equation, and I have to write it so that I only have one unknown. Right now I have two unknowns. Really what I'm looking for is the x. I know the mean. The question states the mean, 53,495. I know the standard deviation. The question also states the standard deviation at 1,500. So I can figure out the z, though, what z number I need to get that 0, 1 to the left of my z value. So as I look in the middle of the chart, I want to see where I find 0.01 in the middle and see what row and what column I would get that 0.01. So 0.01, what row and what column would that be in? So the way the chart is set up, there's 4 places after the decimal. So what you're really looking for is 0.0100. If you can find that in the middle of the chart, and you look at what row and what column intersect to give you the 0.0100 number, you'll have the z number, and then you'll only have one unknown. Now, as you look through the chart, you'll see that actually this number doesn't show up. But you get very close. Right in that area, you'll find 0.0099. That's almost 0.100. And it's as close as you're going to reasonably get. And when you find that and realize that that's the one you'll have to go with, you'll see it's in the negative 2.3 row and the 0.03 column. There's my value for z. Negative 2.33. Now that I have z, I only have one unknown, the x. I know the mean, 53,495. I know the standard deviation, 1,500. So let's write my z-score formula with my one unknown and do the algebra necessary to isolate the unknown, the x. So we start with z, negative 2.33, equals x, the number of miles, this is what we're looking for, that would have only 1% to the left of it, minus the mean. I know the mean. It's 53,495. That's the mean over the standard deviation, 1,500. So now I have an equation with only one unknown. So apply some algebra to it until you get the x by itself. And basically the rule for algebra is you can do anything you want if it's an equation as long as you do the same thing on both sides. So to start this process, I'd rather not have it as a fraction. So this 1,500 on the bottom, I'd love to get rid of that. And I can do it. I can multiply both sides times 1,500. As long as I do both sides, it's OK. So I'm going to do the left side of the equation times 1,500 is equal to the right side of the equation over 1,500. So times 1,500. So I did the left side of the equation times 1,500, the right side of the equation times 1,500. So now, on the left side, 1,500 times negative 2.33 will be negative 3,495. You'd probably want to use your calculator to get that. But that is what it comes out to. 1,500 times negative 2.33 is negative 3,495. Don't lose negative. It'll make a big difference. And then on the right side of the equation, some stuff over 1,500 times 1,500, the 1,500s cancel. So just by canceling the denominator, it already looks much nicer. I have negative 3,495 equals x minus 53,495. The negative makes it look a little weird. You might question whether or not you've made an error, but it's actually fine. You have to pay attention. So to get the x by itself, I want to get rid of the 53,495 next to it. So on both sides, I will add 53,495 plus 53,495 on the left side plus 53,495 on the right side. And now on the left, negative 3,495 plus positive 53,495. You get 50,000 on the left side of the equation. Oops, need one more zero. And on the right side, x minus 53,495 plus 53,495. X. So we have x equals 50,000, which is a realistic warranty, mileage warranty for a tire. So if they provide, the manufacturer provides a 50,000 mile warranty on that tire, they can expect to replace only 1% of the tires they sell. The other 99% will make it to that 50,000 and beyond, and the company gets to keep their money for selling the tire.